All right, this is lesson 4.6 on probability. Remember that probability is the total number of ways to succeed divided by the total number of outcomes. And I'm going to show two problems today, number 13 on page 227 and number 16, A and B on page 227. They're both from lesson 4.6 on probability. Number 13 says, when 3 dice are rolled, find the probability of getting a sum of 7. Well, if you roll 3 dice, there's 6 different ways that first die can land, 6 different ways the second die can land, and 6 different ways the third die can land. So if we multiply those together, that comes out to 216 possible outcomes. So when we find our probability, the denominator is going to be 216 because that's the total number of outcomes possible. Next, we have to find how many ways we can succeed. We're trying to get a sum of 7. So let's list those out. You could get a 1, a 3, and a 3. That would be a sum of 7. Or the first die could be a 3, the second one a 1, the third one a 3. Or the first 2 could be 3s, and the last die could be a 1. Or we could have a 2, and a 3. Or the 3 could come second, 2, 3, 2. Or the 3 could come first, 3, 2, 2. So there's 6 ways so far that we could succeed. Another way to succeed would be a 4, a 2, and a 1. Those would add up to 7. Or a 4, a 1, and a 2, just switching the 1 and the 2. Or the first die could be a 1, the second one a 2, the third one a 4. Or a 1, a 4, then a 2. Or we could have the 2 come first. We could have a 2, a 1, then a 4, or a 2, a 4, and then a 1. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then the last, the only other outcomes I can think of would be maybe a 5, a 1, and a 1. Or we could have the 1 come on the first die, the 5 on the second die, and then a 1 on the third die. Or a 1 on the first die, a 1 on the second die, and a 5 on the last die. I think that's all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 ways you can succeed out of 216 possible outcomes. And then of course we want to reduce that. We could divide both these by 3 and you come up with 5 over 72. So there's a 5 out of 72 chance that when you roll 3 dice, you're going to get a sum of 7. All right, moving on to number 16. A on page 227. Using the information in exercise 52 and section 4.5, find the probability of each poker hand. So this poker hand is going to be 5 cards dealt, and we want to find the probability of a royal flush. A royal flush would be getting an ace, a king, a queen, a jack, and a 10. And that could happen in hearts, diamonds, clubs, or spades. So there's really 4 ways we can succeed. We have to get these 5 cards. The order we get them doesn't matter, so we're going to use combinations. But we have to get those 5 cards exactly in one of the 4 suits. Either all hearts, all diamonds, all clubs, or all spades. So there's 4 ways to succeed. Number of possible outcomes. Well, that'd be the number of ways that we can choose 5 cards out of a deck of 52. To calculate that, remember the formula for combinations is you take your n value of 52, so 52 factorial, divided by, and then n minus r, 52 minus 5, which would be 47 factorial, and then 5 factorial. And you can type that into your calculator. If you go to math, push the math button, go over to probability menu, and the 4th choice is your factorial button. If you take 4 divided by this total comes out to 2,598,960. And then you can divide both numerator and denominator by 4, come up with a final answer, 1 out of 649,740. So if you were dealt 649,740 poker hands, where you got 5 cards, on average, one time you would get a royal flush. And that's 16A. Last up, 16B. 16B is what's the probability of a straight flush. The word flush means that all 5 cards are going to be the same suit, but it's not a royal flush. A royal flush means it has to be the top 5 cards. A straight flush just means it has to be 5 cards in a row, 5 successive cards, but they don't have to be the top 5 cards. So it could be a royal flush, ace through 10, so there's one way, or it could be king through 9, that's 2, queen through 8, that's 3, jack through 7, 4, or it could be 10 through 6, that's 5 ways, or 9 through 5, that's 6 ways, or 8 through 4, that's 7 ways, or 7 through 3, that's 8 ways, or you could get the lowest 5 numbers, 6 through 2, so that's 9 ways. But keep in mind, let's say this is hearts, for example, that could happen in any of 4 suits. So 9 times 4, 4 suits, that we could succeed in 36 ways. So there are 36 ways to succeed in getting a straight flush. Again, the total number of outcomes, we're getting 5 cards out of a deck of 52. So we're going to have 36 over 2,598,960 again. And of course you could reduce that. They're both even numbers, so you could divide by 2 and reduce with your calculator, maybe even divide by more than that eventually. But reduce that to lowest terms and you'd be done with 16.